Okay, we've now done the introduction to differentiation, and we've done some rules for differentiation just for single term expressions, single term functions. Now we're going to have further rules for differentiation. And most differentiation rules initially are intuitive, means it's pretty obvious, but some aren't. Some you would think would work one way, but don't. So it's typical of maths, of course. But so let's have a look at these further rules. The derivative of a sum or difference is equal to the sum or difference of the derivatives. So what I mean here is if we have f of x equals 6x to the 5 plus 3x squared. Now, if we want the derivative of that sum, we can just differentiate that first term and differentiate the second term. So it's the derivative of the first term plus derivative of the second term. And that's what we mean by sum of derivatives. So there we are. 5 multiplies down, 30x, subtract 1, 4. 2 multiplies down, 6x, subtract 1, 1. Same thing happens with subtraction. We can differentiate. So to do that, this becomes 3x to the quarter, and this becomes 4 over 3 x to the minus 3. There we are. X to the quarter, fourth root. 4 over 3, the 4 over 3 is still there, and we invert or bring the x cubed to the top, and it becomes x to the minus 3. Now we can differentiate each of them separately. So we'll have a quarter multiplies down, and we subtract 1 off the quarter, minus the minus 3 multiplies down, there it is, times the 4 over 3x to the, and we subtract 1 off the exponent. So it's just the same as we were doing before, but they're just two in the same question. Of course, that's now changed to a plus because of the double negative multiplying. And I've taken it back to the same format in which they're presented to us. It was presented to us because we were presented as the fourth root. I'll take this back to fourth root. It's now negative 3/4, so it's the fourth root below now because it's negative 1/4. And that is x to the 4 there. Derivative product is equal. Question, not equal. The derivative of a product is not equal to the product of the derivatives. If you have 6x to the 5 times 3x squared, we cannot say 30x to the 4 times 6x to the 1. We have to do the product first. Derivative of quotient is also not equal to the quotient of the derivatives. If I have 6x to the 5 over 3x squared, I cannot differentiate the top and differentiate the bottom and end up with the correct answer. So not equal to. Dealing with products. First expand the products and then differentiate. So when I say expand, I mean simplify as well. So we have that there, that becomes 18x to the 7. Now we can differentiate. 7 times 18, 7 minus 1. This one here, 2 brackets multiplying, don't differentiate 3 there and 1 there from this, because it is not the correct answer. It's almost as if you differentiated twice. Multiply it out first, there we are, it's become a trinomial. Now we can differentiate. 6x to the 2 minus 1 minus 1x, because there's a 1 there, 1x to the 0, which is just 1. This one here, we must square out our brackets. Now we can differentiate. Quotients. Same thing, complete the division, then differentiate. This one here, we can do the division, because 3 into 6 and x squared into x to the 5. There we are. Now we can differentiate. This one here, there's no common factor of x above to take out to cancel with this x. But what we're going to have to do then is write this as three separate factors. This really means that each of the three terms is divided by x. So we're going to do just that. There we are. X goes into that, that, and that. So we're going to write 3x squared over x minus 7x over x plus 5 over x. Now we can simplify those a little because 3x squared over x, we end up with 3x. In this one, the x's cancel. And that one we must write as 5x to the minus 1. Now we can differentiate. The 7 minus 7 goes because it's constant. It's really 7x to the 0, and the 0 multiplies down. 3, this one's become minus because minus 1 times 5 is minus 5. X to the, subtract 1 off the negative 1. And there we have it, writing with positive exponent. This one here is a problem. It can't be done. The division can't be done. There's no further we can get with that. We can't, that doesn't help. You see, I've written it as partial fractions now. I'm sure you remember partial fractions, and that is correct. That does become that. But it doesn't help, because we still have a binomial denominator which cannot divide into the top. We cannot differentiate the denominator separately. So it cannot be done, but we will be doing it in a couple of weeks' time when we have more complex calculus to be able to do this sort of quotient. This one here, at face value, perhaps it cannot be done, but we're going to do as we did in grade 9, I think. We're going to try to factorize that first to see if x plus 1 is a factor. And it is. That becomes x plus 1 times 3x minus 10. Now we can cancel the x plus 1s. We end up with just 3x minus 10. And that we can differentiate. Just becomes 3. This one here, same thing now as a couple of examples before. We're dividing by a single term. 2 terms up top, so each of those must be divided by the root x, which means it's like that. Now I'm going to take root x to be x to the half. So therefore I'll have x to the 1, so divided by x to the half. 1 minus half is half. And this is going to invert to x to the minus 2. We cannot differentiate x to the half in the denominator. Now we can differentiate by normal rules. And write back with positive exponents. If you wrote 2x to the half below and 2x to the 3 over 2 below, you would be fine. That would be full marks. Some more exercises for you. So pause, try these exercises out before you go to the answers. Let's have a look at the answers now. Here we are. I've applied the rule straight in. Derivative, derivative, derivative. The derivative of the constant 5 becomes 0 and it's gone. Multiply out first. There we are. Now we can differentiate. Multiply out first. Differentiate 3 terms. Differentiate, differentiate, differentiate. Multiply out. Differentiate. Multiply out. Square the bracket. Now we can differentiate. 4 gone. That 4 is gone because, of course, it's a constant, and derivative of a constant is 0. Multiply out first. It's a difference of cubes, in fact. Now we can differentiate that it's simply down to 3x squared. We can write that as 2 terms. We need to divide x into both. which becomes 4 plus 7x to the minus 1. Now we can differentiate that. The constant goes, and minus 7x to the minus 2, which we should write with positive exponents. Square out the top, and then write them as separate fractions. There are 3 divisions to be done here, and write them in simplest form but with negative exponents. Now we can differentiate. That constant's going to go again, but these two are going to give results half minus 2x to the minus 1 minus 2, and we're now going to write with positive exponents. So we're going to put the x to the minus 2 below as x squared. This one here, binomial divided by binomial, but we can factorize the top line, difference of squares. X minus 5 cancels, we're left with x plus 5, and now we can differentiate. Here, we can write root x as x to the half, and it divides into both. There are 2 divisions. There we are. So it gives you x to the half because it's 1 minus a half, and x to the minus half. Now we can differentiate. Write back with positive exponents. There we are. I haven't gone back to the root form, but you won't lose marks for that. So we try factorizing first. Oh yes, it does factorize, and the 2x minus 1s can cancel. So we have x minus 1. Very simple differentiation. Same here. 2 separate fractions. Subtract 1 off 1.5, subtract 1 off a half to give you a negative half. Now we can differentiate. Half multiplies down, half minus 1, negative 1. Negative half multiplies down, give you plus a half. Subtract 1 off negative half, negative 3 over 2. And we write with positive exponents.